So hi everyone. So today in this video I will explain how definite integration is connected to a limit of sum, right? That is, so definite integration as a limit of sum. So we know that suppose this is a function, right? This is a function y equals to fx, and this is our x-axis x dash, and this is our y-axis y dash. Now this is a, suppose this is a function and this is x equals to a and this is x equals to b. So what will be this point? This point will be b comma f of b, and what will be that point? This will be a comma f of a. Now we know that the geometrical interpretation of a to b fx dx is nothing but the area of this region, right? Now how we connect this integration with limit of sum? So suppose we have to um, calculate the area of this region. So what we do, we just do this region separated by some rectangles like this. These are all rectangles. We differentiate this type of rectangle is in this region, right? So let us suppose this point is x equals to a plus h, and this point is x equals to a plus 2h, similarly like this, and this point is nothing but a plus n minus 1 into h. Now how to calculate the area? We just doing the sum of these rectangles. Suppose these are all rectangles, right? There is some error, we will fix this later, but for now let us consider these are all rectangles. So area of these rectangles will be what? This is the distance h, and this is the fa. This point is f of a plus h, like this. So what will be area? So area will be h into f of a. Now second rectangle plus h into f of a plus h dot dot dot. The last rectangle will be h into f of a plus n minus 1 into h, right? So this will be the area. But here we mentioned that some error is there because this is not exactly like a rectangle. So to fix this error, we will what we will do, we will do this rectangle so small that it looks like exactly a rectangle. To do this, what we have to do, we just taking limit both side. So area will be nothing but, so area will be limit h tends to 0. How this limit we get? We are doing this h b minus a by n. That means we get h how? B minus a, last point minus first point, by total number of intervals. So h tends to 0 into h f of a plus h f of a plus h plus dot 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 plus h f of a plus n minus 1 into h, right? Now this is the area. Now we already know that this area is nothing but a integration a to b fx dx. So if we write this h tends to 0, we are writing this as a sum. So every term has h, so h summation, suppose f of this is a plus r minus 1 into h. So what will be the limit of r? R will be r equals to 1 to n, right? So this is the relation between integration and limit of sum. Okay, now let us take an example. The most easy example will be, suppose y equals to x. So the graph will be like this. This is our y equals to x, right? So this is our x, y equals to x. And suppose we are taking this from 0, a is our 0 and b is our 1. So this is our a, this is our b is 1. That means this is our x equals to 1. Now when we integrate integration y dx, this is in 0 to 1. So this is integration x dx. So we get 0 to 1. So this is x square by 2, 0 to 1. So it will be 1 by 2. These things we get with direct integration. Now if we do with limit of sum, what we get? So integration 0 to 1 x dx. This will be nothing but the limit h tends to 0. So f of a, h into f of a. What is f of a? So our a is 0. So f of 0 plus f of 0 plus h plus f of 0 plus 2h, like this, plus dot 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 plus f of 0 plus n minus 1 into h, right? So now equals to limit h tends to 0. What is our f of 0? Our f of x is x, right? So what will be the f of 0? This will be 0 plus what will be the f of h? Will be h plus what will be the f of 0 plus 2h? It will be 2h plus dot 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 plus n minus 1 into h, this. So equals to limit h tends to 0. If we take common h, then what we get? Here was 1h, so h square. So this will be 1 plus 2 plus dot 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 plus n minus 1. So this is nothing but a sum of first n minus 1 numbers. So limit h tends to 0, h square into, it will be n minus 1 into n plus 1 by 2. Sum we know the formula. So this we get. So equals to limit h tends to 0, h square into n minus 1 into n divided by 2. Now equals to limit h tends to 0. This is in h. Suppose we get this h here and also here. So this will be nh minus h by this 2. So what is nh? We know that nh equals to b minus a. Now b is our 1, a is our 0. So this will be 1. So what we get from here? This will be limit h tends to 0. nh means, so nh is our 1. So 1 into 1 minus h divided by 2. So if we put 0 limit here, so it will be 1 by 2. Now we can see that we get that answer from limit of sum. We also get that answer from the integration. So both things are same. Now if we do in another way, suppose we have to do the area of this. So what will be the area? So we know area will be, this is a triangle, right angle triangle. So area of this right angle triangle will be 1 by 2 into this base. So this base is 1. So 1 into this height. So this height is 1, since this is 1 and this is y equals to x. So this point is 1 comma 1. So this will be also 1. So we can see that area is also 1. So we get and we get answer from all the side is same. Like we integrate this, we get 1 by 2. We get derive the derivative, we derive the area, we get 1 by 2, and also we derive the sum, we get 1 by 2. So these things is can be understandable, and you can see how definite integration is related to the limit of sum and area. Okay, so thank you so much for watching this video, and you can give me feedback whatever you feel. and also if you like this video you can share with your friends. Okay, so thank you everyone.